All right, hello. Welcome to the SF Pug March 2026 meetup. I'm your host, Catherine Saar. Before we begin, this meeting is being recorded and will be posted on YouTube afterward. Everyone who speaks during today's event will be part of the recording. We'll do a Q&A at the end of the presentation. If you choose to ask a question, your voice and image, if your camera is on when speaking, will be part of the recording. If you do not ask a question, you will not be part of the recording. If you're using the most recent version of the app, which we recommend, you can use the raise hand function to join the queue. If you're using an older version of the app, which does not have this function, please use the chat to let the organizers know you would like to ask a question, and they will add you to the queue. The organizer will let you know when you're next in the queue, so you can be ready to unmute your microphone and ask your question. If you don't want to be part of the recording, the organizers can convey your question to the speaker. In that case, please type out your question in full and let the organizers know you would like them to present it to the speaker. If you have any technical issues, please message the organizers for assistance. If you drop out of the meeting and are unable to rejoin, you can post a message on the event page on Meetup, which we're monitoring during the presentation. SF Pug Bay Area Postgres is a PGUS affiliated user group, and I am a volunteer for PGUS. SF Pug is sponsored by PGUS, or I'm sorry, SF Pug is sponsored by PGX, and I work for PGX. Thank you for joining us, and here is Keith Fiske with Extension Development Lessons from Partitioning and Monitoring.
Thank you, Catherine. Thanks everybody for coming today. So, who am I? My name's Keith Fiske. I'm a software engineer with Snowflake. I was part of the acquisition of Crunchy Data back in June of last year at Snowflake. I've been using PostgreSQL since about version 8.2 or so, and I'm the maintainer of one popular extension, pgpartman, and pgmonitor, and several other extensions in Postgres that have kind of come and gone. And a little bit about me: I'm avid video game player, have 2 dogs, a couple birds, and a gardening I kind of got into in the last year or so. So, going to jump right into it. So, what this talk is really about is just kind of situations that I've come across as I've been developing extensions, and like some best practices, and just some small things and tips and tricks for doing extension development in Postgres. Not so much really like any in-depth coding too much, well, we'll see here. So the first thing that that I usually do in my extension development that is a little bit different is my file organization. But when you make an extension, and most of my extensions too are PL/PGSQL based. I don't do a lot of C development. I do have a few C tips in here, but most of this is more around PL/PGSQL and that portion of the extension development. And when you do that, the file that you have to give to Postgres, you have to give it a single file with the extension name, -- the version number, and then the SQL extension. Actually, that second dash there is accidental. I don't think that should be there. But so what I typically do to make development for myself a little easier is, like, so for example, in pgpartman, there's quite a lot of SQL file functions, and trying to so this is just the functions, and I also have procedures and tables and other pieces of it. Trying to manage all of that in one file, and like it just is a little unwieldy. So what I actually do is, you can see I have this, I make this SQL folder, and I like split things out into the different object types and procedures. I typically have the procedure split out from the functions, because I've been working on this since before procedures existed, so I had to have a way to distinguish between the two of them for this sort of purpose. And so what I do is I keep each individual object in its own file, and then I use the make file, and when it actually goes and builds the extension, to pull all of those files together. So this is all file here is like the end result of the function name of the extension that talked about up here. And then what it does is it goes through and cats all of those different um, uh, files together in all those different folders to make that final extension version, or that extension file that Postgres requires to actually do the installation. So that's just makes it easier for myself to do individual changes in files and keep track of things easier. And then when you do extension updates, I actually have, and I just use Impartment as an example here, I make a separate updates folder for all of those, because you can see over time they can build up a little bit. So I just kind of have them in their own folder. That makes it easier to do. And then, but as far as Postgres is concerned, when you're installing the extension to the files to where they're supposed to go, the update files and that extension file all need to go to the same place in the end. And so that's what that in the make file, that data definition just grabs all of those update files as well as the SQL file and puts them over in that in the required folder together for what they're doing. And and then just to talk about updates and extensions in general, the file naming format is the old version, then the new version with the extension name at the beginning. It provides both upgrade and it can technically provide a downgrade path as well. But I haven't done downgrades myself. I haven't seen any extensions that actually support that, but it is possible because Postgres doesn't actually care what these values here are. They don't even have to be numbers. It could be alpha, beta, and whatever you want to name your versions. All Postgres knows is this version, and the between the two sets of dashes there is less than that last version. That's all Postgres knows. So, and that's how it keeps track of things. And so when you see this giant list of updates and you have all these updates are installed, it just goes down the list and makes an upgrade path based on all of these files being consistent and having a path between all of those files to do your updates. So technically somebody could be all the way back in version 2.0 and run this all the way up to 5.4 and it should work if it's supported. I have some caveats in the major versions in the release notes for PG Partman, but there is an upgrade path for all of that. The thing to note is those whenever you run an update, and if you make an object, even if you only intended it to be temporary or you didn't want it to be part of the extension, any object created as part of the update will become a part of that extension. So if you don't want it to be part of the extension, you have to figure something out, or just like make a temporary object, or make sure you drop it at the end if it's not supposed to be sticking around and being part of the extension itself. The updates do run in a single transaction. So if a change requires multiple transactions to go through, you will have to run all of those individual updates one at a time. And you can see the one example here that I have. So like if your existing version is 1.2.3 and you're trying to go to 2.0, if there's multiple updates between 1.2.3 and 2.0, it will run all of those updates in a single transaction. So if you, for some reason, you need to split those up, there are some things like around triggers and can't remember though. There's another thing, but the thing I usually ran into is if you had like triggers and stuff involved, or dependencies between objects with views and things like that, you may need to do things in separate transactions. And so you just do an alter extension update command for each individual version to go through that and run each has its own transaction. There are a few examples of that happening in Partman's history if you're curious and want to go back and look at that in the release notes, or if you have any questions, I can talk about that. Let's see. If you need to skip a version, like say you broke something, and I have certainly broken things in my experience here, you can skip a version. And the thing to note is when you're doing these update files, Postgres always uses the shortest possible path to get from your starting version to the last version. If you're going to be supporting downgrades, you have to be very, very careful, because if your shortest path would follow that downgrade, even though you're going like down and back up again. If that's the shortest path to get to where it's going, it will take that. So just be careful of this if you are trying to support downgrades. But you can just make a file that will skip that version. So in this example here, this is an old extension I used to work on where I had to do this. I had to skip version 0.10.0. There was, I think there was like a syntax error in there for specific versions of Postgres, and I just happened to miss that the one time when I was going through there. So in order to skip that, instead of going from 0.9.3 to 0.10.0 and then back from 0.10.0 to 0.10.1, I just make a file that goes from 0.9.3 to 0.10.1, and it will skip over that because that's the shortest path to get from 9.3 to 10.1. And you can actually see this in Postgres. You can ask Postgres to show you the update paths that an extension will take to get from one version to another. And you'll see that they're to get from the shortest path to get from 0.9.3 to 1 is this one file right here. And so that's the path it's going to take to do that. But if you do this kind of thing, it also allows, if somebody was successfully able to install your version that you're skipping, you still do want to make that file that zero. So in this case, I want to skip 0.10.0. What if somebody was successfully able to install that? You still want to make that file to go from 10.0 to 10.1. So for those people that were successfully able to get that, you have to be able to provide them that path to get to the next version of that. But this allows you to make update files to skip the versions that may be broken. So any questions on version management and like file management and stuff with extensions so far? Okay. Another neat feature. So a lot of extensions, it's kind of a personal preference thing at this point. I can go either way. Some extensions will explicitly install to specific schemas, and you really can't have a choice in what schema it goes into. That's perfectly fine. And some extensions may require that you have to be in a specific schema for whatever reason. There's dependencies between different extensions and things like that that you want them to work together. But in the case of Partman and most of the extensions I worked on, they're kind of all independent, and I had no need to require it being in a specific schema. But you still need to be able to schema qualify things when you're calling them, when you're calling your objects and things. So Postgres provides this macro that you can put in your PLPGSQL code. And so this is what it will look like in the code itself. So I'm calling this other function that exists within my same schema. And then when you run either the install or the update of that extension, it will just whatever schema was set when the extension was installed, it'll just replace that macro with that schema. And speaking of schemas, you always want to schema qualify everything as much as you possibly can when you're doing this sort of stuff. From experience, not doing that can, oops, I want to click that. You can get a nice 9.8 level CVE when you don't do things like that. So this is my one and only CVE that I've had to do in my experience so far. But this is just a lesson learned in schema qualifying your objects, especially if you're going to do security definer. What security definer functions in Postgres are is usually when you run a function, you're running as whoever it's a user, a security user, or I can't remember the term for it. Usually it runs as the person that's calling the function. If you make a function security definer, it runs as whoever the owner of the function is. So if the owner is a super user, your function is running as a super user when it runs. So it's very critical if you're using security definer. I would recommend not doing that if you don't have to. I used to have to do it in older versions for specific things. So either explicitly schema qualify things, or you can specify a limited search path for the functions. And that's actually something. So back when I fixed that CVE, I fixed it in those specific instances. But more recently, in a more recent version of Partman, I actually went back and made sure I explicitly had the schemas set for, or the search paths set for every function that needed it, that I could do it for. So basically, I went back to the beginning of every function, and a function has this set option you can do to set a search path, and then it only has it set for the local run of the function, and it goes back to what it was normally. One caveat to that I ran into with procedures, though, is if your procedure does commits within itself, has embedded transactions in the procedure, you cannot do that set at the beginning. So for my procedures, I just went back through and all my functions and everything as much as I could to make sure they were all schema qualified as much as I possibly could in that case. So that was a big lesson learned there on proper search path maintenance in Postgres. Another thing you can do, the tables can be a little bit tricky with extensions. I would recommend them only being used for configuration data if possible. Because if the extension, when Postgres does a dump and restore of a database or something like that, it does not dump out individual extension objects. Because when it runs the restore, all the restore does is run the create extension command. It doesn't recreate all of your old objects, and so it does not add any data back you may have had before. But what you can do is you can configure an extension table to dump its data out. And I do that for the configuration tables in Partman, and it's a relatively small table. It's not that big of a deal. It just has the configuration data for all of the partition tables that it manages. And you can actually add a where clause to it. Otherwise, all the data is dumped. An example of this is if you have a configuration table that you want to have some pre-existing data in all the time, you don't want it to dump out that pre-existing data, because that data will be recreated whenever the extension is recreated again. So you can exclude data you don't want to be dumped out with this option. The thing to be careful of with this, and I'm pretty sure this is still the case in PG18, this data is always dumped. Even if you do a schema dump, it dumps this data out because it's considered part of schema. So if you have a large table that is part of an extension, you will get all of the data dumped out in a schema dump unless you explicitly filter that table out of doing the PG dump. So just be aware of that. It's why I kind of say this is really only for configuration data, or data that's, if you're going to have a table in an extension, it's not data that needs to be kept. It's just like ephemeral data that doesn't really matter. It doesn't need to be dumped and restored whenever the database is dumped and restored. So, this is just a thing that I ran into. If you're adding new columns to a table that is part of an extension, I know some people like to have, and for a while I did myself. It was kind of you like having your columns in a certain order in a table, even though it really doesn't matter. In the end, it was just kind of like an aesthetics thing. But that can actually cause a problem that I found out. So if you go and add a column in and you rearrange, go and add the column into the middle of the order of the columns, and later go and do a dump and restore, and you're restoring a different when you remember when I said when you run a restore, it just runs create extension. So if you have a new version of the extension that gets installed when that happens, and you have columns in a different order, the data may not restore properly because the order of the values doesn't match up with the order of the columns when it's doing the copy command and things like that in a dump restore. So if you're adding new columns in an extensions table, just add it onto the end and live with that being the order of your columns for the remainder of your extension's life. It'll just be the way it is, and it'll just avoid issues in the future with that sort of thing. Let's see. Sorry about that. I turned the phone off, but apparently I didn't. Oh yeah, so for future maintenance of your extension objects. So Postgres does have some automatic object naming for things like for indexes and constraints and things like that. You don't have to give them a name. Postgres will automatically name them. I would highly recommend you always explicitly name every possible object that could be being created by your extension, including like all of the sub objects inside of your objects and things like that. That's so, like, say later you come to realize you have to alter a constraint or you have to drop an index or something like that. If you let Postgres automatically name it, you have no idea what that name is. You could probably try and look it up in the catalog to figure it out, but you may not be 100% sure that's what it actually is. But if you named it in the first place, you know what it'll be in the future. So that's my recommendation is just name everything you can possibly name. So if you have to go back to and modify it or drop it or do something with it later, you can just explicitly name it and you'll know you're working on the exact object you need. And another reason for this too is because of the way that automatic object naming is done can be a little wonky sometimes, especially with indexes and constraints, like multi-column indexes and things like that can really get crazy sometimes. But because Postgres has a 63 byte limit, not character, byte. So if you have a multi-byte alphabet or whatever you're using, you'll have less characters you can use in your object names. So if you ever run into this, if you ever try to make an object name that has more than 63 bytes in its name, you'll see Postgres give you back a warning that it's truncating the name of your object. It'll go ahead and create it anyway, but it'll truncate it and it'll tell you what the truncated name is, or you can go back and look and see what it is. That's another reason for this. So you can imagine, like index names and like multi-column indexes can get really crazy. If Postgres if a Postgres name would collide with itself in the future for things, it just starts adding ones and just starts adding an incremental number at the end of it. So you get IDX1, IDX2, IDX3 instead of names of indexes that are something consistent with what you might look up. So that's something like that. And another issue that I ran into with Partman, and I made a function to kind of work around this, is partitioning with Postgres. Since you name all of the child tables yourself, it's usually done with a suffix on the end of it. So like a date or a number that's always going up or something like that. That and if Postgres truncated off the end of that, you lose your logical naming of your object or things like that, or you can even run into naming collisions and things like that. So I wrote this function. So what it does, it actually truncates the original parent table name and then adds a suffix onto the end of it. So the suffix in Partman's child tables is never cut off because I'm trying to preemptively manage that. So it's another reason to name your indexes and all that kind of stuff beforehand, because you may not know that Postgres may truncate it off as well, and then you'll really never know what the name of it was. So another thing I ran into with managing extensions is some changes, like if you needed to change the signature of a function, or like if your function returns a table or something like that, you can't just do a create or replace on that. You have to add or remove that original function or object to recreate it. So, but when you do that, you would lose the privileges that a user may have added onto those objects for other people to do. So it's a thing that I started doing in my Partman and other extensions, was to preemptively kind of try to save the let's see if I get back to there. Save those old object privileges and reapply them. So let's see if I can find one where I did that, just to see. I was doing that. Did I have to do that here? Sorry. One of the minor ones. Yeah. So this is an example of just I'm dropping in and restoring some procedures and functions, and so I just create this temporary table. I make the new grant statement on the new object, and then I pull out what the old privileges on the old object were in that case. And I actually ran into an issue with public because public is tricky. It's like an all capital special macro word key for like granting things to the built-in public role. But you can't. It's like it's different than lowercase public, but if you put it in quotes, it considers it literal. So I just basically kind of just ignore the public grant altogether. There's a caveat in the documentation. It's just I have no way to preserve a public grant on something, but functions and procedures by default are granted execute privileges to public. So it's only really a problem if you've revoked public from an object that it may put public back onto that object you revoked it from. But that's the thing I kind of do to try to help make the extension easier to manage for the future, that you're not constantly losing your object privileges every time you have to install an update to an extension, if those objects had to be recreated for some reason. Just some other notes, like maintain version compatibility between many different versions of Postgres, or if you need to explicitly exclude some version that you're not supporting anymore. Like for right now, I usually tried to always support the most, like the current versions of Postgres that are being supported. But when version 5 of PGPartman came out, I had to cut off versions older than 14 a lot earlier, because there was a feature that I needed to use in 14. I wanted to be able to have the background worker run procedures. You couldn't have a background worker run procedures before Postgres 14. So I just made Postgres 14 the lower limit of PGPartman for right now. So you can, there's just a simple function you can use in your PLPGSQL code to just look. It's called the current setting server version number, and it's just a 6-digit integer that you can compare against for easily do comparisons against to do version comparisons. The little bit of C code I have in here, you can also do this in your, in your C code. There's this macro, the PG version number, and you can just do this version checking in your C code to call different functions for different versions of Postgres. Oops, I think I hit back. Yep. And then also in the make file, if you're wanting to say you have this is the old version. The bottom one was the old kind of messy version of version comparison I used to do when I used to have to do a different install procedure. I had to do a different install procedure for version 11 than I had to do for older versions, because version 11 of Postgres is when they introduced procedures. So obviously all the procedures I had, if you tried to that was another good reason for having all of the files separate instead of just being in one giant file, is when I would dynamically pull the file together, I could explicitly exclude the procedures, so I would be able to install Partman on versions older than 11 that didn't support procedures yet. So this was my old code in the make file for managing multiple versions. Now I don't have to worry about that too much anymore. It's a little cleaner that I can do this here, that just have the minimum version supported for Postgres in that case. This is just a recommendation that I ran into. I tried to use enums and when I first started out for some of the configuration tables and stuff like that. The problem with enums is you can't remove values from an enum. Postgres made the ability to update them at some point, but you can never delete them. So enums, unless you have a specific need that you must use an enum, I would highly recommend just doing a check constraint instead. You get the same functionality. It may not be as performant as what you may need as an enum would be, but the functionality is exactly the same. And then if you need to update the check constraint, all you got to do is update your function, and you can literally have it be whatever you want it to be inside the contents of the function. You can, if you want to prevent people from like trying to run your SQL file directly, like just like doing PSQL-F on your extension file, and you want to give them a clean error message to say you have to install this as an extension. If you actually look at the contrib modules that PostgreSQL comes with, it has this in the SQL extension file. It just puts this little echo at the top. And quits. The normal extension, when you run create extension, it just doesn't even read that. It just looks right over it. So if you're splitting your SQL objects out into individual files, it'll have to be whatever your first object in that concatenation of files is going to be. I actually didn't have that in my example. I actually, in my make file in partman, I actually have them sorting things, I believe, now. Where's that? Oh, actually, no, I stopped doing that here. I guess because it didn't really matter for me anymore. I used to have it do a sort at the beginning of each of these. So it would always be a predictable alphabetical order. But that would be one way that you could always ensure that which one of them is your first file. Another handy thing, this is more, I guess, more of maybe a documentation thing for people, but it's also, I mean, it's handy in general that if you need to write a couple hundred alter table statements for whatever reason when you're doing something, instead of trying to write all that out or trying to have something outside of PostgreSQL generate that, you can just do that right inside Postgres by looking up the system catalogs and having it write things for you. So this is an example. I actually changed in version 5 of partman. I don't support like this old week number partitioning scheme anymore. So I had to provide people a way to convert their existing tables to the new just standard year, month, day format. And so this kind of looks the old table names up in all of the tables that are part of the partition set, and it gives you a whole list of alter table statements to update all of your table names and make sure you're getting the right consistent name for all of them easily. Let's see. For doing this is just debugging, not just for extensions, but basically for like any PostgreSQL code or schema testing, whatever you're kind of doing. This PGTAP extension, I use this like extensively in partman. It's the reason partman has stayed as relatively bug free. It's not bug free, but it's saved me a lot of headache and making sure things work for the most part every time I do an update in Postgres and then in partman or whatever extension I'm working on. So it just has functions and things to make sure your object and your data exists in the state that you expect them to be in. The only downside I've run into it is procedural testing. Like the entire unit test has to run in a single transaction. So for procedural testing, I kind of have to do like run the tests, then go do something outside of the test, then go back and run another test again. So that's a little one downside of it. But like I said, like roughly like a couple thousand tests in partman all doing this, and so it's helped me keep this extension pretty stable over time. Another one that I use every once in a while is basically a linter for PLPGSQL code. The big thing that catches for me is like when I stop using a variable and it just doesn't need to be in there anymore, and can check for some SQL injection vulnerabilities and things like that. So it's a very handy, another handy extension for Postgres to help you doing basically any code development in PLPGSQL. So So outside of extensions, just because I said this was lessons learned from monitoring and extension development, but I learned this as part of doing some other monitoring extension development. Um, just a tip for doing monitoring in Postgres. You usually want your monitoring queries to be relatively quick. Because you're the thing that's doing the scraping, like either Nagios or Prometheus or whatever, is scraping on a regular basis, like every 10 seconds or 30 seconds or something like that. So all of your monitoring queries need to tend to run pretty quick, so you get that stuff back relatively quick. The one thing I would routinely run into is as a database got larger, the database size and table size metric would get slower and slower depending on the resources that were given to the database. And so as that query would take longer and longer to run, the scraping of the metrics and stuff would take longer and longer to do, eventually kind of timing out at a point where like you start getting into multi-terabyte databases, they can take a long time to give you back that size metric. So what I started doing was making use of materialized views to capture any long running query metrics. I would turn them into a materialized view, and then have the scraping tool query the materialized view, and then have something else on the back end that would refresh the that metric in a time period that would work better for the table size. Like the table size one that I was running into is sometimes taking like up to like a minute and a half to 2 minutes to run, just because it was just a slow IO system, and that's what it took to get the size of the database when I would do that. So I didn't really need that metric more often than every 10 or 20 minutes. So I just set the materialized view to refresh every 10 minutes instead of every time the scrape ran, and then so it would work even though the scrape was running every 30 seconds, it would only get new data every 10 minutes in reality on that. So another thing you could do, but before materialized views exist, the other thing you could do would have a view on top of two alternating tables. So you'd have something refreshing the non-active table on the back end, and then when it was done, it would come and swap just do a create or replace view, and have the view look at the new table with the new data, and then once that was done, it would go refresh the other table and swap things back and forth like that. So depending on your situation, that may be better than doing a materialized view, but it's just another idea. So some other things are still missing in core for things that I ran into as far as doing like partitioning and things. Global indexes is one that's still missing for partitioning. That's like having one index one unique index that can cover an entire partition set that's not part of the partition key. You still can't do that yet in Postgres. The reason that pgpartman kind of still exists is because there's no auto generation of child partitions in Postgres. If that ever comes around, pgpartman may be obsolete. I'm okay with that. Please, I'd rather everybody have things built in core than needing to have third-party tools allow people to do things like that. One thing that I ran into with unlogged tables in Postgres, and an unlogged table basically is a table that kind of skips the wall stream, but it also makes it much faster to write to. Prior to PostgreSQL 18, you could set the unlogged flag on a partition set, but it would not apply it to any of the child tables. And there was really no way to do that, within Postgres natively. But now PostgreSQL 18 explicitly disallows you from setting a parent table as unlogged. You just can't do it anymore. So you have to set the unlogged flag on each individual child table in Postgres. That's what I was doing before, just to avoid this issue as well. So Partman has a template table you can set things on for things that you can't do the actual table, parent table itself. And the other thing that's still missing, so the materialized views that I was talking about don't automatically refresh in Postgres. You have to have something that will refresh them for you on the back end. Hopefully that will have some way to do that in the future, or just like an incrementally updating materialized view would be great feature to have. So that's kind of my lessons learned, and it's just some tips for doing extension development in Postgres, and some monitoring tips from doing that as well. So that is it. If anybody has any questions, I can stick around.
All right. Do we have any questions for Keith? That was a lot of great information. Thank you so much.
Sure.
Anybody, any questions? Okay, you covered a lot of territory, Keith, and that was really, really awesome. Thank you so much. I'd also like to thank PGUS and PGX. The next SF Pug, we're still working on the details for our April meetup, but we will notify you as soon as it's available. Upcoming conferences are PGConf Dev, which is May 19th through the 22nd in Vancouver, British Columbia. PG Day Boston is June 9th at the Museum of Science in Boston. PG Summit US, formerly PGConf NYC, will be September 30th through October 2nd in New York City. And PGEU has just been announced. It will be October 20th through 23rd in Valencia, Spain. We will send a link by email when the video is ready, and you can watch our social media. You can find us on LinkedIn, Mastodon, and Blue Sky by searching for Bay Area Postgres. We're looking for speakers for 2026, so if you or someone you know is interested, please contact us. Thank you again, everyone who attended, and thank you so much, Keith, for speaking for us again. Hope everyone has a great rest of your day. Stacey also says thank you, Keith, and we will see you all next time. Thanks so much.
Thanks.